Well, bonjour, welcome to this video on key features of graphs day 2. In this video we're going to talk about increasing and decreasing functions, where graphs are increasing, decreasing. Sounds pretty intuitive, right? And where functions are positive and where they are negative. Our objective, make sure you get this down, is that students will be able to identify when a function is increasing or decreasing, positive or negative. That is our objective. Okay, yesterday, or I guess today we talked about identifying domain, range, asymptotes, and intercepts of functions. Just really quickly going over these guys. This one I feel like you guys should be able to do this. So I'm going to do this one first, and I want you guys to try this one on your own. But here my domain is all of my x values, so that's, since I have an arrow pointing this way, right, I know the function continues out this way, so that's starting all the way at negative infinity, and my arrow, right, I have an arrow going this way, so I know my domain is negative infinity to positive infinity with parentheses. I don't include, so I don't have any brackets. My range, that is my y values. Remember, here I have an arrow going down, and it's going down, and I have this exponential function which starts to kind of tail off here. Now when it does this, there's actually an asymptote at this line, which is f of x equals 1. I have an asymptote at f of x equals positive 1. Now when I have an asymptote, that limits my range, right? That's like a force field that you cannot cross. So my range, it starts at negative infinity and it goes all the way up to positive 1. Okay, and actually, since there's an asymptote, I'm not going to include that, right? I'm never going to cross that. I'm never going to touch one. So I use a parenthesis just as if it was infinity. My intercepts, I have an intercept here that crosses through the origin, and that is both an x-intercept and a y-intercept crossing at the origin. Okay, please go ahead, pause the video, and try this one on your own. Okay, hopefully you tried this one. For domain, my x values go from negative 9 all the way to 7. And my range values, let's say, what, negative 2.5? I don't know, to 5. So I'm going to say negative 9 to 7. And range values was negative 2.5 all the way to 5. If you said negative 3 here, I'm okay with that. If you said negative 2, I'm okay. That's kind of unambiguous, right? It's right in between. So I just went with negative 2.5. Linear function here, right? There's no asymptotes here. This is non-applicable. And my intercepts, aquí. So my x-intercept is negative 4, comma 0. That's here. And my y-intercept, here, since this is my y-axis, x-axis, this is 0, comma 2. Okay. All right. Our objective today, we want to identify when a function's increasing and decreasing. A function's increasing if it is going up from left to right. So then it's increasing when it is going up from left to right. Pretty intuitive, right? If I have a positive slope, that function is increasing. I have a decreasing function, similarly, if my function is going down from left to right. So the easy way to tell is just like reading a book. You go from left to right, and if the function is going down, then it's decreasing. If it's going up, then it's increasing. In Math 1, we specifically look at linear functions, correct? Right? Straight lines that go up or go down, and exponential functions that have growth going up or decay, right? They go down. So all of these are either increasing or they are decreasing. I don't believe, in our notes we don't look at any other situations. So these are always going to be increasing for the real numbers or always going to be decreasing. Please make sure you get these down in your notes, these definitions. And we're additionally going to talk about positive and negative, when a function is positive, when it is negative. A function is positive when it is above the x-axis. So I'm going to use green for positive. Here's my x-axis, correct? Well, my function is positive when it's above. So when it's above, this is the make or break line. So you see here at this point, my function is positive. So it's above. Okay, so my function is positive starting here at -1. And we're going to describe this with domain values, and we'll look at some examples here in a second. So from -1 to infinity, it is positive. Notice how -1 is not included, and that is because at -1, my function is crossing, right? So at -1, the value of y is 0, so it's a neutral value here. But as soon as I pass -1, sorry, it is positive. A function is negative when it is below the x-axis. So it's negative when it's below. So at -1, right, it is negative all the way to -infinity. And in interval notation, we say from -infinity to -1. We don't include infinities, and at -1, it's neutral. It's neither negative nor positive, so I don't include -1. And that's what this is saying. This piece is, that's what this piece is saying right here, right? And again, we describe this with domain, okay? The kind of common misconception is positive, negative. You guys will do well identifying that when you're down here, right, we're negative, and then when we go up here, we're positive. But people tend to describe it with y values. Do not do that. Again, do not describe with your range values. Right? Do not describe. I'll put a big circle around this. Don't do that, okay? Right here. Here's ding. Actually, I shouldn't make it red. I'll make it green. Ding. Right? So we're going to use domain to describe those. Make sure you get those in your notes. Write down those definitions, right? You can pause now if you want. Or rewind. You do you. Boo boo. Okay, so here's our first example. And we talked about domain for this function, right? Starting at -6, going all the way to 4. So that would be -6 to 4. I'm not really concerned about that a lot, and my x-intercept being right here at -2, 0. I'm more concerned with the increasing, decreasing, and positive, negative. So this function is always increasing. It is always increasing. It is positive and negative. Okay, here's the tricky one, when it's above the x-axis, and negative when it is below. So I first want to focus on positive. And I'm going to use highlighter. If you have a highlighter, feel free to highlight. So it's positive all the way here. So here's where it's positive. Now it starts being positive at -2. So at -2, right, at my intercept, -2, it is positive. Okay, I'm not going to include it because it's neutral, right? Its y value is 0. It's not positive. And it goes positive all the way up until to 4. And we include that because I have a solid point. If this was an arrow like this, then it would be infinity. However, it's not. Okay, my function is negative when it is below the x-axis, when it's below. So for all of this values, right, it's negative. So what domain values is it negative? Well, from -2 to this value, to -4. So in interval notation, we use lowest value first, right? So -4 inclusive to -2. And we do not include -2. Here I have an exponential example, and for this one, my domain is the all the real values, right? I have arrows this way to the left, arrow to the right, so my domain is -infinity to positive infinity. And my x-intercept specifically is right here at +2, so 2, 0. Now, increasing, decreasing is this function as I move from left to right, right? Left to right. So I go this way. Is it going up or going down? Well, it's going down, so therefore it's decreasing. I circle decreasing. And now I want to talk about where is it positive and where is this function negative. So this function is positive when it's above the x-axis. So when it's above, you agree it's positive for all of these values, right? Positive, 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 neutral here. So my function is positive, and we're going to use domain to describe. Okay, again, I'll write this. Use domain values to describe positive, negative. Okay, so my function is positive from negative infinity all the way up until 2. Okay, 2 it's neutral, so I do not include parentheses. It's not brackets. And then at 2, it dips below the x-axis. It dips below. And for all of these values, say this function continues to go down like this, it is negative. Well, what domain values describe this? So starting at 2, all the way until forever, right? To infinity, it is negative. So we're going to say from 2 to positive infinity. Okay, easy enough, right? Muy fácil. All right. This one is slightly different. I want to go ahead. I'll do this one with you, and then I'll give you the one practice problem at the end. Domain, it's exponential function, so domain is the set of all real numbers, right? Negative infinity to positive infinity. And my x-intercept, this one's a little tricky. Let's say right here, negative 5.5. We're going to make it a little difficult on you. Negative 5.5 comma 0. So this function, as I go from left to right, what's it doing? Left to right. Well, it's going down on a Thursday. It is a decreasing function. Okay, and positive, negative, where's this function positive? Well, it is positive once it goes up this way, right? At negative 5.5. I wish this was like... Actually, let's not make it green. Let's make it red. Okay, like this. Okay, now it's extending. So at negative 5.5 all the way this way, it is positive, and I'll bust out my highlighter. Boom, right? It's positive all the way up from here. Okay, so what domain values? Well, from negative infinity up until this point, it's positive. So we say positive from negative infinity to negative 5.5, and that's that with parentheses. It is negative when it dips below. So all the way to negative. Okay, so what domain values describe that? Well, negative 5.5 all the way to positive infinity. So negative 5.5. I want red. Curve game strong. Taking green out. Negative 5.5 to positive infinity. Don't be thrown off that we're describing negative values and it's below that I'm using positive infinity to describe this. That's okay. That's okay, right? Negative 5.5 to infinity. Okay, please go ahead, pause the video, and try this one on your own. Alright, so hopefully you paused this and tried this. I'm going to quickly finish this up. I have about a minute left. So my domain is negative infinity to infinity, and my x-intercept is here at 2, 0. As I go from left to right, it is going up, and that is increasing. The function's positive when it's above the x-axis, which is up here. It crosses at 2, and it goes up. So what domain values describe this? Well, at 2 all the way this way, all those domain values. So that is 2 to infinity. It is positive. It is negative when it is below. So here it is negative. So that's from negative infinity, right? Negative infinity all the way to 2. Negative infinity, comma 2. Okay, hopefully you got that right. I'm sure you did. Closure, how do we identify if a graph is positive or negative? Well, it's positive when it's above the x-axis, and it's negative when it's below. Don't forget, like my video, subscribe. Oh, and Cynthia wanted me to say Schwartz the Berg, and Tony wanted me to say Poppyberg out.